Hello AS Math, it's Mr. Knight, not coming to you from the school, but rather my bedroom. So that's why the environment looks a little different. Figure, hey, why work at the school when I could just work in the comfort of my own home? So here I am. Okay, we're going to continue on from last lesson, which was looking at functions. And this time we're going to be looking at something called a composite function. Maybe you guys have worked with this before. Maybe you haven't. So if this is new, buckle in, okay? It's not too bad. So here's our skills that we're going to go over. Creating a composite, but also solving composites and what that looks like. And I got a question. So how would we go about solving this function right here? X to the fourth plus 3x squared plus 2. We've seen something like this before when we are working with quadratics, okay? And this is what we did before. So we're going to come down here, and I'll start off this problem how we would normally start it. We need to get this to look like ax squared plus bx plus c, right? So in order to do that, we need to do some kind of u substitution. So normally we do u equals x squared, and then this would all become u to the second power plus 3u plus 2, and then we'd go about solving that like normal, okay? This substitution right here is basically what you could do with composition of functions, okay? A composite function is a function composed of a function, or a function of a function. So that's kind of like a rough definition, okay? But think of it as like a function within a function. And that's kind of what we're doing here. I'm declaring a new variable, but I'm using kind of like the similar inputs to kind of make this work together. So for example, if I have u equals x squared, you can see every time I have an x squared term, I'm going to substitute u in for it, right? Well, what if I did this instead? What if I said this was g of x? G of x equals x squared. Okay? Nothing really changed. Nothing really changed. But basically what we'd be doing with this guy and how they work together is we could do f of g of x, right? I'm taking this g of x and I'm now plugging it in for the x here, for the f of x. So now this f of g of x literally becomes the u squared plus 3u plus 2. It turns it into that, okay? So you guys have actually been working with the ideas of composite functions this whole time without even fully realizing it, okay? So let's jump into an example, okay? So we're given f of x equals 2x, g of x equals x squared, and h of x equals 1 over x. I restricted the domain x cannot equal 0 because we have an indeterminate form, right? So now I want us to find these four composite functions. Now they're written kind of different, right? They're written kind of weird. So we're going to go through what they actually look like, and let's see. So for this first one, for A, okay, we're doing f of g of x. So another way to write this or think about this, we go from right to left when it comes to composing functions. This turns into f of g of x, essentially, okay? So I know my f of x is 2x, and I know g of x is x squared. So basically what this is telling me to do is to plug in my g of x function in for x, for f of x. So every time there's an x in f of x, I'm going to be plugging in my g of x. So this will turn into f of, well, we know what g of x is, it's x squared. I don't know if you guys can hear my dogs. F of x squared, and I'm going to plug in x squared for x, right? And so now if I multiply this, I get 2x squared. Okay, and that's it. 2x squared is the same thing as f of g of x in this case, okay? So I know they're right next to each other. That does not mean multiply. Again, this is how we set up composing our functions. Let's see it again. This time we're going the opposite way, okay? We're not going to get the same thing because order does matter in this case. So again, this is like g of f of x. And if you want to write it like this in your homework, by all means do it if it helps you. I like it because I get to see very clearly what I have to substitute in. So this is g of whatever f of x is. We said f of x was 2x. And so g of x is x squared. So for x, I'm going to plug in my 2x. And now I square that. Using the power rule, this applies to the 2 and the x. So I have 4x squared, which is different than this guy up here. So the order definitely matters, okay? Now, what if I give you something like this? Well, if you see f to the second power of x, this is really, this is not doing f of x twice. That's not what that is. That's not doing f of x to the second power. So I wouldn't be doing like 2x to the second power, which is kind of what we did over here, right? That is not what that means. This instead actually means I'm going to do f of x. Okay? That's how I want to set that up, all right? So let's take it over here now. Well, I have f of x. F of x was 2x, right? So now f of 2x equals, well, I got to throw 2x in for the x. So now I have 2, and then in for x was 2x. So this will equal, after multiplying, 4x. Okay? That is f to the second power of x, or doing f of x twice. Okay? But you don't have to limit it to just 2 compositions. I could do 3 compositions. Okay? So we said, again, I'm going to rewrite this because I want us to have them. F of x equals 2x, g of x equals x squared, and we also know h of x equals 1 over x. We go from right to left, okay? This is the same thing as f of g of h of x. And we're going to work inside and work our way out, okay? So let's see what h of x was. It was 1 over x. So I'm going to do f of g of 1 over x. Well, what is g of 1 over x? Well, now I got to plug in 1 over x for x squared. Okay? So let's come over here. Let's do g of 1 over x and figure out what that is. Okay? That's the same thing as 1 over x to the second power, like that. Again, using the power rule, I take this guy, I come to the top, come to the bottom, and I would be left with 1 over x squared, like that. This guy right here, now, this guy right here is exactly what I want to plug in for this guy right here. Okay? That right there. That g of 1 of x equals 1 over x squared. So now what I do is I do f of 1 over x squared. So you can see how I'm kind of taking these guys and I'm transforming them, right? I'm taking what they are, plugging it in, and just kind of working my way out. All right? So let's continuing on. Now I just take this 1 over x squared, plug it in, and read x for f of x. So f of x is 2x, right? So this is going to become 2 times 1 over x squared. Multiply the top. This is 2 over x squared. And that is the same thing as f g h of x. Okay? So getting used to the notation and kind of the order of everything is really the key with problems like this, okay? But I also want to make a consideration. I want us to consider the domain and range for a second. Because if you're kind of seeing this, right? If I take, let's say this first example right here. If I take my g of x, right? My g of x has some kind of domain, right? The domain could be, let's say, all real numbers, right? Well, now I'm plugging in, I have the domain, right? And so I'm getting range values out of it for here, right? So my g of x is representing my range values. So if I plug in 2 for my input, I'll get a 4 for my y, for my output. Well, now those outputs are becoming the new inputs of this f of x, right? So the domain and range kind of have this give and take with them, right? So let's see that in this next example, how there might be a consequence of that. So if I'm considering f of x equals 2x, and now I'm saying x exists within all real numbers, and I have g of x which equals the square root of x, and I'm stating that x has to be greater than 0, or else I'll get an imaginary number. I want to find this now. Well, that's the same thing as f of g of x, right? So now I got to take my g of x, whatever that function is, and plug it in to my f. So I'm basically doing this, right? So now if I plug this guy in for f of x, I'm going to get 2 times the square root of x, right? Well, this function right here is still saying that x is within all real numbers. But I could tell you right off the bat, if I plug in -1 for this, it's not going to work. I'm going to get an imaginary. So I actually cannot do this. I can't find f of g of x due to domain restrictions. There would be a way to fix it, though. A quick fix would be to do this. Instead of saying this is within all real numbers, I could just say a new domain. I'm going to state instead that it's going to be within, actually, it's not going to be within anything. I need it to be greater than 0. I need it to be greater than 0 in order to satisfy this. Now, if I say this is, instead, x is greater than 0 for my f of x, now I can plug in a suitable domain. 1 would work, 2 would work, 3 would work, right? So I don't get these weird answers or undoable composites, okay? So something to keep in mind when going through this. And finally, let's see what this is going to look like when I actually solve for things, right? So now I'm not just doing f of g of x, I'm doing f of g of 2, okay? So now I'm given f of x equals x cubed, and I'm given g of x equals 2x, and I'm given h of x equals x plus 2 within all real numbers. So now I need to find this. So this is the same thing as f of g of 2. Well, what would g of 2 be? G of 2 would be 2 times 2, right? If I'm plugging in the 2. So this would be 2 times 2 is 4. And now this becomes f of, well, g of 2 is 4. So now what is f of 4? I plug my 4 in for my x, for f of x. 4 times 4 times 4 is 64. And that is f of g of 2. Okay? Let's see it with number, or letter b, not number b, even though we're kind of in algebra stuff, b numbers. We have something like this now. This is f of h to the second power of 0. This looks like kind of similar to what we were doing a little bit earlier, right? When we were looking at part C on this one. But now we have 2 of these guys. So let's see what that might look like. Well, I'm doing f of h of 0 twice. So I'm really doing f of h of f of h is what I'm doing. And this is, of course, of 0. Okay, make sure my parentheses 1, 2, 3, that looks good. Okay, now let's see what we can do with it. Okay, again, h of 0. I plug 0 in for h. I get 2. So this becomes now f of h of f of 2. Right? So far so good. F of 2 now. F of 2 is just going to be 2 cubed, which is 8. So now f of 2 becomes 8. F of h of 8. And you guys can see what's going on, right? We just keep repeating the process. H of 8 is going to be 10. Now it's f of 10. And finally, f of 10 is going to be 10 to the third power, which is just 1,000. So 1,000 is equal to f of h to the second power of 0. Okay, so try to get used to rewriting this out and making it look like that. Remember, you start from inside and work your way out. In this case, we had to do that twice, right? If this was to the third power, then I would have to, of course, do f of h of f of h of f of h, right? Hopefully we don't run into any of those like that, okay? This is Mr. Knight with Composite Functions, signing out.